Application-specific data processing. The subsampled point cloud in section 3.2 was used for the 3D surface reconstruction. Point cloud comprises a set of dense 3D XYZ points of the surface, but, in reality, the discrete point data do not offer sufficient description of the cave structure. 3D mesh generation was done in MeshLab 1.3.4 beta to reconstruct the cave in its true 3D geometry. MeshLab is an open-source package for point cloud processing, advanced mesh generation and editing. A number of surface reconstruction approaches are available in the software, but the widely used Poisson surface reconstruction approach was applied in this present lecture. The algorithm utilizes the sampled points from the surface and the gradient of the indicator function, a normal field, to build surface. The gradient of indicator function was derived by computing normals for the point sets using 10-point neighborhood kernel. The procedure converts the point normal into a solid 3D surface by defining a scalar function that best matches the vector field to build a fitting isosurface. The 3D meshed surface was achieved with octree depth of 10 comprising 825,451 vertices and 1,650,604 faces. Octree depth parameter sets the depth of the octree used for extracting the final surface. Increasing the octree depth parameter increases the precision and level of details, faces and vertices, of the surface. However, compromise had to be made among level of details, visual reality and real-time interaction with the model. The final mesh model was used for analyzing the general cave passage structural morphology and morphometry and also for the sectional drawing. Documenting micro-morphological features requires high-resolution textured 3D model. Advances in computational efficiency of point cloud processing software like Autodesk Recap and its textural 3D rendering capability will rapidly revolutionize cave investigation. Despite the tremendous success achieved with TLS survey in many notable caves around the world, photorealistic 3D rendering of cave has remained unattainable. Besides the limitation of the existing point cloud processing software in handling large volume of data, overcoming the problem of total darkness has been a subject of intensive research. Today, archaeological documentation using 3D scanning is considered the best method. Nevertheless, the use of two independent sensors, laser scanning and digital photos, throws up additional challenge. The difficulties include managing illumination variation, finding exact match between the images and geometric model, and handling the volume of data acquired. Besides, processing the data involves several manual operations. As an alternative approach to RGB, red, blue and green, photos, the laser intensity value attached to each point was used as a substitute for the texture-based virtual reality rendering. In this study, we used Autodesk Recap 360 Student License Package, http://www.autodesk.com. Recap 360 is one of the families of Autodesk products specifically designed for handling massive cloud point and photo dataset. It is innovative 3D modeling and reality capture software that create complex 3D model with real-world visualization by combining laser scans and photos. The package supports a number 3D file formats including CL3, Topcon, E57, FLS, Faro, LOS, PCG, PTG, Leica, PTS, PTX, RCS, Text, XYZ and ZFS, Zoller plus Fraux. Moreover, it computationally optimizes input files by indexing to its native RCP file format for efficient processing, modeling and interactive visualization. The model allows complete natural feel of the rock such that all details of the irregular surfaces including rock engraving and artworks in their true 3D geometry are captured. Understanding cave use, especially in the past, requires detailed true-to-life perception of the space in all dimensions including the morphogenesis of the floor, ceiling and wall caused by geological and, at times, biological factors. For Gomantong Cave, no reference is found in the literature indicating cultural utilization of the subterranean space in the past outside nest harvesting. This aspect of our study aims at identifying micro-morphologic features and relict antiquity from the high-resolution 3D texture model that could provide insight into factors that influence passage modification and enhances our knowledge of probable age-long use of the cave.